Check out a Mini Cooper R53 master brake cylinder, which we see right here. It's a piece of aluminum, and we have one brake line coming out there and the other one coming out on the other side. Sitting on top is a brake fluid reservoir, and these two lines over here to the ABS module. Here's the yellow one, and that goes into a port with the letters PC, which I believe stands for primary circuit, and the other one goes into secondary circuit, which is over here. And then the ABS does its magic and then sends the brake fluid pressure through those other pipes out to the calipers into the wheels. So we're going to take a look at this master brake cylinder. It's called a tandem brake cylinder right here, and we'll take a look at the inside of that and how it works. Here's the master cylinder taken out of the vehicle, and we have the shaft from the brake booster will push right through here, and the brake pedal would make the booster move. So basically the brake pedal input comes right here, pushes on this shaft. Brake fluid reservoir sits on top of here like that. Make sure that there's fluid all the way, always on top of that, which feeds inside, and I'll show you what all that means in a minute. And then as this shaft is pushed in, it builds pressure in the hydraulic brake fluid here, and this port down here is for the dynamic stability control. All Minis don't have that. All vehicles don't have it. So sometimes you'll just see the outlets to the brakes here, but this actually feeds a computer, which helps with the ABS algorithms. And so that's what that looks like when it's whole. And here's one. I'll reverse this. This is the view we were just looking at. If we look at the back of it, where I was able to cut it open, then we can see there's two different areas in here. This is the secondary circuit, and if we look closely, I believe you can see, if I get a light, you can see the hole. I believe we can see it now. See the hole to the port right in the center. It should be focused right now. So you can see how that pressure, this volume in here, exits through this hole right here. And that's because that hole is drilled all the way through and has access to this volume in here. So as this brake pedal is pushed and the shaft moves in, then it transfers that load over to this spring and to this shaft, which in turn pushes this whole assembly, and with this O-ring produces a pressure in this volume right here. And there's a second, actually they call it the primary circuit, I believe. So this would be the primary volume. It's back here. You can't really see it right now until I start pushing on it a little bit more, but that creates a pressure between this O-ring and another O-ring a little bit to the left. And that creates a pressure which goes out through that port in the center of the screen. And so that both of those go to the ABS, which I have over here when I said the primary circuit. So we have the primary circuit which feeds in here. So that would actually come from the left-hand opening, the one that's in the center of the screen. I believe that's what they call primary. And so let's take a look as we disassemble it. Disassembling this master cylinder is not that easy. So the first thing you see is it has this retaining clip in here, and it does not have holes in it to get it loose, or to compress it in so you can get it out. So that makes me believe they really don't want people rebuilding this master cylinder. So I had to basically I tried drilling holes in the side of this and treating it like it was a regular snap ring and tried to get it out, but really I couldn't get it. So I ended up having to I just cut it on this side. Here's a snap ring, so you can see where I drilled holes trying to remove it, and ultimately I just said, okay, forget that, I'm just going to cut the thing in half. And so that obviously was a lot faster. And I went ahead and did a cross section so you can see. So this is a piece of plastic, the coffee colored part on top, and has the O-ring bonded to it on the bottom. And then there's a metal O-ring right here. Not an O-ring, there's a washer. Okay, so I got that washer turned. I cut a section out of that too, so you see the washer there, right there. And then there's a hole in this shaft right there. I'm putting the screwdriver inside of it, and a pin goes inside there. Let's see, where is the pin? Got it somewhere around here. Here's the pin. So that pin right there goes inside that hole, and it just retains the whole shaft from coming out. So that pin would actually butt up against this metal washer, that steel washer, stainless steel. And so that's how the whole assembly is kept together. As we pull this thing apart, we get to understand it a lot better. So here's the initial shaft I mentioned. And so the primary volume is right here between this and the other O-ring, which is right there. So let's see if I can get this out. All right, so here's the other piece that comes out. Again, so if we imagine this being inside, so we can see how this moves up and down and creates pressure on this end here. There's also pressure generated within this cavity here, and that's the one, remember the exits, that port right there. So it's pretty simple. Now there's interesting sort of features on the way the fluid gets in there, and I'll show you a little bit more on the computer animation, but basically you see those holes, there's 3 holes, the smaller 2 drain fluid into this area right here, and it's able to go this way due to the nature of that O-ring. You can see that it'll let flow go that way, but it will resist flow going this way because the inside of that seal has pressure and will actually, when the pressure begins to build up in this volume here, this will actually seal even harder and harder against the internal surface of the master cylinder. And this one lets flow go this direction. And that happens through those 2 holes, which come out right there. And it might be a little more obvious when I show the computer drawing how the fluid gets to this area right here, and then is able, basically this whole master cylinder is filled with brake fluid, and that's the way you want it all the time. And so these little ports allow that to happen. Here's a sketch of the master cylinder, and I'll let you get used to this for a second. Just a side view, kind of straight on, idealistic, mostly to scale, pretty close, but this is in PowerPoint, so it's not going to be exact. One thing I wanted to point out are the fittings for those 3 brake fluid fittings there. They're metric 12 by 1. So let me just sort of mock up how you would assemble this thing. So we saw this on the video earlier. This would be the first item we put in here. Let me bring that to the front so it looks more reasonable. We have this second element that we can install here. Now, what happens is during installation is this front piece, I'm just going to sort of manually compress this spring a little bit. So this front piece is compressed at least about that much so that you can get this pin down through here. So that pin goes like that. This is actually rotated 90 degrees, so it would go through this hole. So, this is not, you got to have a little bit of mental gymnastics here to see what I'm talking about, but I think that's pretty reasonable. I can bring that to the front as well. So then you'd have the second piece that you can then insert a little bit farther.
And then there's another pin before you put on the washer and the retaining pin. Here you put this pin through that hole. Let me just bring that to the front as well. And this thing floats up and down, so it's not static, and it prevents this piece from moving out. So if this tries to move out, it's going to be blocked right there by that metal washer that I showed you earlier on the video. So just wanted to show from the master cylinder how the primary circuit and secondary circuit are attached to the anti-lock brake system, and this is a Teves Mark 60 unit that comes on all the Minis and a lot of other cars. And so this is on the, if you're looking at the hood, looking at the windshield, it'll be on the left-hand side of the car, or it's on the passenger side for US cars. And then you'll see the lines running to the wheel calipers from here. So again, I'm pretty sure PC and SC stands for secondary and primary circuit, not positive, but I am positive that it's this particular fitting that goes to the PC. Let's go to the next one. And this, again, just expands the diagram to go to the calipers. And from what I can tell, the primary circuit feed looks like it goes to the front right and rear left brake calipers. And that's because of where these fittings are located on the ABS unit itself. They're kind of next to the PC input, and similarly with the other ones are near the secondary circuit. And so I have read that the Mini uses a diagonally split system, so that would make sense. So I talked about the O-rings and how the brake fluid goes from the reservoir to fill this area. So this is just a little animation to show you for the primary volume and secondary volume how the fluid goes past this O-ring and into this volume. And similarly over here, it travels over here, will be in this volume, and then can go past that O-ring. Ultimately, the whole area, the whole volume is filled with brake fluid. And so just to animate the sequence here, not in super high precision, but you have the pedal force, the brake pedal pushes on the brake booster, which then has a shaft which pushes on the master cylinder right here. And you can see I do have representation of that O-ring right there. And so the high pressure builds in this volume and this volume, shown by the red areas there. And this is the one that feeds the secondary circuit, and I deleted it just for clarity here, but that other, this volume here delivers the primary circuit, which has a intake about right here.